in this video. Hello everybody, and welcome to the 51st video on the channel. Let's get right into the lesson because there's not too much to say. A lot of the stuff I said in the previous videos. But as always, please make sure to like, subscribe, and hit that notification button for more awesome videos just like this. And please go down in the comment section and comment down below what topics I should do next. If you have any more advanced geometry theorems that you'd like me to cover, or maybe an algebra concept that's necessary, please make sure to put it down in the comments so I can always improve my channel. Alright, let's move on to the lesson. Today's lesson is actually quite simple. It's about the unit circle. So the unit circle is kind of like it's kind of like a coordinate plane, but it's a little different. It's split up into 4 quadrants. The first quadrant is where the angle, or theta, is from 0 to 90 degrees, or 0 to pi over 2 radians. The second quadrant is from 90 to 180 degrees. The third quadrant is from 180 degrees to 270 degrees. And the fourth quadrant is from 270 degrees to 360 degrees, or 0 degrees, and that completes a full rotation. So, that's pretty much about it for the basic quadrant part, but there is actually one more thing. Now, you can say cosine theta is kind of like x and sine theta is kind of like y. Now, in the first quadrant, both of them are positive. In the second quadrant, cosine theta is negative and sine theta is positive. Kind of like what happens with x and y in the second quadrant. In the third quadrant, both of them are negative. So that's also kind of what happens in regular Cartesian coordinates, or like Cartesian geometry, or like the regular coordinate plane. And in the fourth quadrant, pretty predictable, we have x and negative y, where y is now negative and x is now positive. And then it just loops on itself all over again. So yeah, it's in fact pretty simple. That's another quadrant thing. Now, the other purpose of a unit circle is when the unit circle is used quite frequently. The unit circle is used quite frequently is to figure out common angle measures. Normally in a trigonometry book at the very end, or even a calculus book, at the very end there will be the unit circle. Now the unit circle will have like 30 degrees, 60 degrees, 90 degrees, 120. It will go by 30-degree measures and give you the sine and cosine for the angles. So because those are very common, and sometimes they'll also give you 45 because 45 is also very common. So I'll show you a few common angle measures from 0 degrees to 90 degrees, and then show you again how to calculate some of the other ones using those basic ones. So let's move on to, I think, the second part of this lesson, which is more of the common angle measure. Alright, so for our common angle measures, we're going to start with 30 degrees. Now, or pi over 6 radians. I've done a video explaining a little bit about degrees and radians, but before I do this, I want to explain something more. Degrees and radians are 2 different ways of measuring an angle. And I'm pretty sure you know what an angle is. Because if you've seen my geometry videos, a shameless plug, please make sure you do. They're very good for understanding. Now, make sure you watch them. And it's going to definitely help you define what an angle is, what a point is, what a line is. It's some very basic geometry stuff. So, there's a way to convert between degrees and radians. 180 degrees is equal to pi radians. The short form for radians is RAD. So, if you want to convert from degrees to radians, you'd be like, okay, so how many degrees do I have? I divide that one by 180 and do pi. So pi by 180 degrees is equal to the amount of radians. So if we do 90 and 180 cancel to 1 and 2, that becomes 90 degrees is equal to pi over 2 radians. So it's pretty simple, and I just wanted to say that. So 30 degrees is pi by 6 radians. So the cosine of 30 degrees, or pi by 6 radians, is equal to the square root of 3 divided by 2. Now, the reason I did this, the reason I'm doing 30 degrees is because it's slightly easier, but normally in trigonometry and when we get into more advanced geometry, it's much easier to use radians because it'll help us understand for pre-calculus and calculus. So when you're doing these different operations like differentiation and integration, it'll be a lot easier for you to do it. So cosine pi by 6 radians is equal to root 3 by 2. It's the same thing. So sine pi by 6 radians is equal to 1 divided by 2. Now let's move on to 45 degrees. 45 degrees, the special thing is cosine theta is equal to sine theta is equal to the square root of 2 divided by 2. So that's about it for 45 degrees. Now for 60 degrees, it's the exact opposite as 30 degrees. Sine pi over 3 radians is equal to root 3 by 2, square root of 3 by 2. And the cosine of 60 degrees, give me a second. The cosine of 60 degrees, or cosine of pi by 3 radians is equal to 1 by 2. Now, the final angle measure that I would like to do is 90 degrees. But first, let me quickly finish writing sine of 60 degrees. That's pretty easy. Sine, not cosine. Sorry. Sine of 60 degrees is equal to the square root of 3 by 2. Finally, what we have is 90 degrees. Now, 90 degrees, sine of 90 degrees, or sine of pi by 2 radians, is equal to 1. But the cosine of pi by 2 radians, or 90 degrees, is equal to 0. For 0, which I haven't mentioned just yet, it's the exact opposite, where cosine of 0 is 1 and sine of 0 is, of course, 0. So that's about it for the first quadrant. And you just do negative, like if we have cosine 120, so for 60 will have around the same magnitude, which I'll explain later in the next video, around the same magnitude of 120 degrees or of like 330 degrees. Wait, no, sorry, 300 degrees, I'm pretty sure. And then 30 degrees has pretty much the same magnitude as 330 degrees or 210 degrees or 150 degrees. So it's pretty much just looking at the corresponding angle for the different quadrants and calculating it from there. Thank you so much for watching. See you in the next one, and bye-bye.